Hi, welcome everyone. My name is Rashid and I have been pre-selected for one of the 15 PhD projects announced under innovative electrochemical oxidation processes. I won't be able to make it to 11 for recruitment process, so therefore I'm making this video. That's another process of presenting someone at a recruitment event. So here we go. I have a master's MSc Chemical Engineering degree from University of Malaya, Malaysia in 2015. We will discuss about it later. Then I worked for another 7 months as a research assistant for synthesis and characterization of superparamagnetic nanoparticles. That happened in Malaysia. Then I got a contract to work at Eindhoven University of Technology, the Netherlands, in July 2016. I started my research work on evaluating mass and heat transfer coefficients for different metallic forms provided by Shell Amsterdam. So currently, I came back to Pakistan in July 2018 and I started working as an assistant manager in April 2019. I started working as an assistant manager for product development and testing of cosmetic products. I'm working at Revolution Dermacare Private Limited. That's a company in Pakistan. I have by now 5 research publications. I have presented my work at different international conferences, and I have published a book, and I have an overall H index of 3 by now. Excuse me. So I have been selected for early stage research program number 8, that is institute production of hydrogen peroxide at the cathode surface via catalytic coating of the cathode surface. So I will present my science and technology background here. So the highlights will be that first I will discuss about my experience with electrochemical cells, then my thesis topic, that was CO2 absorption into monoethylenamine solution. And then I will discuss about characterization and application of nanoparticles, that are iron oxide nanoparticles. Then lastly I will discuss about my experience at Eindhoven University of Technology, where I was working on reactor modeling. So the first slide will represent my undergraduate work for my final year project at Institute of Chemical Engineering and Technology, University of the Punjab, Pakistan. Here I worked on wastewater treatment using electrocoagulation technique. So what I was doing is I was removing chromium, zinc and copper excuse me copper, zinc and chromium salts from simulated electroplating industry using electrocoagulation as a removal technique. So what was happening, I was changing the current density, pollutant concentration and time, and studying the effect of all these things on metal ion removal from wastewater. So how it works is that the cathode sacrifice to produce aluminum hydroxide flocks that are of low density and have high surface area to absorb these pollutants onto the surface of the flock. And based on their low density, these flocks rise to the surface of the water, thereby purifying the water which is in the main electrochemical cell. So these flocks are also promoted to rise to the surface by production of oxygen at the anode. So after they rise to the surface, water becomes pure and pure with respect to time, and then I was taking the samples from the bottom of the column, and I was using the characterization technique, that is atomic absorption spectrum, where I calibrate the atomic absorption spectrum for different concentrations of chromium, zinc and copper to evaluate the component of salt in water at different times. So I received a Best Poster Presentation Award for my research work at 4th Chemical Engineering Symposium in Pakistan in 2010. So the technique which I was using in my research was atomic absorption spectrum. Based on this, I received a scholarship to complete my PhD on a topic which was simulating CO2 absorption in aqueous amine solutions using Aspen HYSYS. That was the starting project. The main idea was that I will not be doing experiments because there are already too many experiments for absorption of CO2 into monoethylene solution. So I started working with the experimental work done by David et al. In 2006. So he was using an absorption column, and he provided all the details of the packing and height and dimensions of the absorption column. He had different carbon dioxide sensors to like to report the concentration of CO2 in different heights of the column at a steady state. So the black dots in the graph represent the experimental data. So the strong line actually is based on the mathematical model used by David et al. To like report the to predict his experimental results, and had 28% deviation from his experimental results. However, when I was using a mind package from Aspen Hysis, I had a very good prediction of the experimental results with only 3% deviation, and that was a very nice day for me, because after that I started publishing my research work. So first thing was to study the temperature profile to know if the absorption is happening in the entire column or only in part of the column. So from the temperature profile, it shows that most of the CO2 is absorbed into aqueous amine solution as soon as it enters from the bottom of the column, and resulting in very high temperature at the bottom of the column, of course with a very high rate of evaporation. However, the temperature of the flue gases was reduced when it come in contact with cold amine solution coming from the top, and most of the vapors are actually condensed back to the liquid phase. So this was the profile. Secondly, I looked into evaporation and loss of loss of these vapors in the flue gas, and change in enthalpy of the vapor phase. That was my second publication in 2015, where I showed that this rise in temperature actually affected not only the flue gases but also the liquid, and can result in formation of stable amine salts that actually result in reduction in amine concentration in the liquid phase. I also did modeling of CO2 absorption for MEA based solution, to absorb CO2 in MEA based solution, and received the Best Poster Award in 2013. I defended my thesis on I graduated on 10th of October 2015 based on this research. So I had two publications, Best Poster Award and a book published from my thesis. After that, I started working on an industrial project. Now this was a very interesting industrial project where I was synthesizing, purifying, coating and characterizing superparamagnetic nanoparticles. So iron oxide nanoparticles were actually the target of this research, because magnetite phase of iron oxide is very good in paramagnetic properties. This means that in presence of electrical magnetic field, they will induce some kind of properties in themselves, and that is very useful. They also exhibit a very high magnetic properties with very low hysteresis loop area. So where was its application? So the industrial counterpart was actually a glove making industry. They were producing these gloves and sending to different kind of customers. So their customers in Japan and Australia have a problem that if a piece of glove is actually teared from a sharp edge of the machine in packing area and drops into the food product, it's really impossible to find out which packet might have the piece of glove, so they have to throw entire batch into sea. However, they wanted to identify the piece of glove, so the idea was to produce these nanoparticles, to coat them with a stable colloidal solution, stable coating agent, so that it makes a very stable colloidal solution in NBR latex, and then after doping you will have a very nice black colored glove which you can see. However, for the food industry, the black color is not good, and they consider that there will be a chance of contamination if they use it like this. So do a double coating. In the second coating, what happens is they coat it with naked NBR latex. So the outer surface which touch the food will never have any kind of contamination. It's already inside, and if it makes into the solution, so a 2 by 2 millimeter, that's a very small size of glove, if it's dropped into the food product, it can be identified by very normal magnetic scanners. So I also worked on coating agents, so that these coating agents not only make colloidal solution but are not affecting the properties of NBR latex. And after the glove is formed, we did FESEM to see the distribution of nanoparticles. So if you can see this picture very nicely, you can see all these bright stars. These are actually nanoparticles distributed on the surface of the magnetic glove. So the glove will have these nanoparticles on the entire surface, and it actually doesn't increase the cost of the product because yeah, very low concentrations of iron oxide are used for doping. So I filed, drafted and filed two patents. One was on design of filer plant, and the second was on magnetic separator, because we were separating these nanoparticles based on their magnetic properties. We used magnet to separate the magnetic nanoparticles from mother liquor, and then we did all kind of purification, coating and characterizations. I received a technology award on 8th Invention Summit in Pakistan in 2019 when I came back to Pakistan this year. I published a paper this year on this topic, and another paper is under review. Characterization techniques which I used during this process was XRD, Raman, because it's pure research on nanoparticles, so I was using all kind of techniques, and also mechanical testing to evaluate the mechanical properties of the glove. Yeah, so this was my project in Malaysia. Then I went to Netherlands to work on another industrial project that was from Shell Amsterdam. So they were sending different kind of metallic forms. So the size of the form was very small with very high surface area, as you can see here. They has like between 2.83 into 10 raised to power 3 to 3.11 into 10 raised to power 3 meter square per meter cube of surface area. That was very high. So they wanted to evaluate initially we have to evaluate the RTD behavior of these forms. So I was using n number of tank model in MATLAB. So what I was doing, I was dosing the liquid with potassium chloride and recording the conductivity using conductivity meter, and then I use a number of tank models to evaluate the behavior. So of course, if you see this spin-disc reactor, it will have a plug flow behavior near the shaft, and then at the edges, because the disc is moving at very high speed, it shows a pure CSTR behavior. And then again, when this gas liquid solution actually come back to the middle of the shaft where there's an exit, it shows a plug flow behavior. Based on this, I calculated the mass transfer coefficient using oxygen sensor for air and water system. Then the heat transfer coefficient was actually measured by a copper rod that was 0.5 millimeter in thickness, and then it had like 3 sensors. It had 3 sensors in the copper rod, which was actually coated into Teflon packing to make a half-inch pipe fitting so that it can be installed into also in pack column and also in spin-disc reactors. I was using Wilhelm-Stutzman model to report the micro-mixing efficiency of spin-disc reactor, and I was using UV waves to record the change in behavior of concentrations in Wilhelm-Stutzman model. This is based on acid-base reaction where there are 2 acids and 1 base, and micromixing is actually evaluated by the fast and intermediate reaction in Wilhelm-Stutzman reaction. So I will discuss a paper which is pre-selected by my supervisor, that is electrochemical catalytic mechanism of N-doped graphene for enhanced hydrogen peroxide yield and in situ degradation of organic pollutants. I will have a session with my supervisor because I'm not coming there, so I have to discuss it with him personally. My soft skills, which I would like to mention here, is that I have worked with Aspen HYSYS for my master's thesis, and I have received published 2 journals and best poster award and a book on this topic, so that is good. About MATLAB, I have used it whenever I need it. I used mostly for n number of tank models to report RTD. I also used it for micromixing efficiency and also for CO2 absorption in mine solutions. I have used ANSYS Fluent 1D model to validate the heat transfer coefficient in temperature profile. That was my work in Netherlands. To report the profile of temperature in the copper rod so that we can have a very accurate temperature at the tip of the column. Okay, after that I have also attended a number of CFD courses because my contract at TU Eindhoven, I had a discussion with my supervisor that I can attend some courses to enhance my knowledge on CFD and open form course softwares. So I have attended some advanced courses here. Yes. Okay, about my soft skills and contribution is that I have a chemical engineering degree. That's a basic strength I have, and I have worked in 3 different countries, so I'm good with international exposure. I have good communication skills. I have 3 best presentation awards. I am okay with MATLAB, and I also have basic knowledge for open forum. Research project, early stage research project number 8 is very good, in line with my research profile, because I worked with electrocoagulation process, and I also have good experience with dealing with nanoparticles or any kind of particles and their characterization. And after that, I also work with spin test reactor and heat transfer probes that are actually based on new technologies which are used for electrochemical oxidation processes. I have all kind of experience with characterization, calibration, and sample preparation. However, it will become more better in the project, but still I have known the techniques for analysis of the surface area, composition, and I have used HPLC and GCMS at Durham University Technology for evaluating the liquid phase reactions. That will be the part of this project, that we will be evaluating the liquid phase reactions using HPLC columns. Okay, then I have good experience in drafting papers, patents, and posters. I have received Best Poster Awards a couple of times, actually 3 times. First one was on industrial wastewater treatment, second was on CO2 absorption, and third recently I received on production of these nanoparticles from Pakistan. I have attended a number of courses in the Dublin University of Technology. These were advanced master's courses to increase my knowledge on reactor modeling and different softwares. How you will contribute to myself? Of course, I will achieve a bigger milestone of my life, that is to get a PhD degree. You will also provide research and training on electrochemical advanced oxidation process and synthesis of modified electrodes. That will be a basic skill, good skill to have. Deep learning on process development, optimization, and data analysis. Of course, it will be industrial project, and we will be doing some real kind of research work with a lot of research outcome. I will have a hand-on experience on another technique that will be used in this project, that will be characterization and analysis of advanced electrodes. And of course I will enjoy my time in Europe, because I already enjoyed it between 2016 and 18 with my wife and 2 kids. I have a son and a daughter. So that will be all, I think. You will not have an opportunity to ask me questions about my research. That is different, but anyhow, I think that will be all. So thank you for your time.